Hello everybody, my name is Saul, and well, we're about to spend the next 30-45 minutes about how Asterisk does run or how it performs in virtualized environments. First, a short disclaimer. English is not my mother tongue, so please, I'll just try my best. And I hope to just learn something, as well as I learned when doing this presentation. Well, a bit about myself, because most of you just don't know me. As I said, my name is Saul, but I'm known as Sagul. I like everything about Void. I discovered Asterisk several years ago, and I've been playing around with it and with all the stuff close to Asterisk. I started testing virtualization solutions more or less 2 years ago. At first it was for playing, but then I saw that it was quite useful. And well, I love everything about free software and GNU Linux in particular. I work at a company called Irontech. We are located at the north of Spain, in the Basque Country. We do web design, VoIP, systems. Well, it's everything we do. We do it with open source software. Are always free software solutions. We're always trying to be at leading edge, so that's one of our characteristics. So, about this presentation, it's already up there. www.irontech.com, that is strange symbol, Saul. You can download it and you will find this presentation in OTT and PDF and all the configuration examples for the Asterisk, the SIPp scenarios, the KDL configuration, the Xen configuration, and also you can find the raw test results which I use to make the graphs that we're about to see. You can download it right now and just look around if you want. Well, first I'd like to know how many of you have used virtualization environments for work or use. Well, quite a few. And from those who use virtualization, how many of you have tried Asterisk on them? Well, some. That's fine. Well, so maybe the first 2 points are not for you, but I'll just introduce a little bit to virtualization, also to what types of virtualization we have, and then I'll describe how the test bench was set up, and then I'll discuss the testing results. As you can see, I just tested Xen, KVM, and the stack server with no virtualization at all. I was about to test VMware ESX, but I couldn't because the hardware platform was not supported. I think it was the hard drive controller. And at last I could test it, but well, the result had to be really close to Xen. Or I think so. So, what is virtualization? Virtualization is the ability to run several simulated machines within one single physical server. Well, this may look a little abstract, but think in costs of space, in costs of servers cost money, and server costs space, and they consume power and all that. So why would we use virtualization? Well, we can have a single server with 2 identical machines, one for testing, one for production, so we can do all sandbox testing in our testing environment and then move it on to the production environment, so nothing happens while we're testing. We can also reduce costs by unifying different servers, virtual servers now, in one single physical machine. For instance, we can have an Apache server and we can have a MySQL server and have both virtualized within one single machine. And we can also have different testing scenarios. For example, we can have a virtual machine with latest Asterisk trunk checkout running on top of CentOS, and another virtual machine with the latest 1.4 branch running Debian. So we can use it for different testing scenarios. Well, within virtualization, we also have different types of doing it, and with by using different types, we can achieve different performance. Each one has its good and bad parts, so I'll just try to explain a little bit. The most important thing about virtualization is the performance we get. As I said, we are running several simulated hosts under one single real one, so performance won't be 100% the same, but we need to be as close as possible. So performance and isolation are two concepts that are really closely related in these terms, because we want our guests to be as isolated as, well, as good isolated as they can be from the host. But this isolation usually gives us less performance. So there are 4 types of mainly used virtualization types. Those are emulation, full virtualization, parallel virtualization, and operating system level virtualization. When we're running emulation, for example with QEMU, the entire hardware is simulated, so we have no access to real hardware. Well, we can usually pass through the USB and all that, but we have no access to real hardware. Guests run unmodified, so we can install our operating system on top of an emulated system, just as normal, and we can virtualize different architectures. Well, performance is usually poor. Full virtualization, here we can have, for example, Xen and also KVM. It's quite similar to emulation, but some CPU instructions are run on the real CPU, on the raw CPU, not on a simulated CPU. For doing this, we need the virtualization extensions from Intel or AMD. Those are Intel Vanderpool or AMD Pacifica extensions. They are called Intel VT or AMD VT. And well, hosts and guests have to be the same architecture. I assume most of you use x86. Guest operating system runs unmodified, and we often use full virtualization instead of parallel virtualization because guest operating system runs unmodified. And as we will see in the next slide, for parallel virtualization we need to modify the guest operating system, and well, with closed source operating systems such as Windows, we can do that. So we can use full virtualization. It gives us better performance than emulation, by the way. Well, in parallel virtualization, guest operating system is modified, so it communicates with some kind of stuff called hypervisor. The hypervisor is an abstraction layer to the real hardware, so the guest operating system will communicate in an easy way with that hypervisor, so the performance achieved is as good as possible. The performance achieved with what? Sorry for that. The performance achieved it's better, so it's the virtualization type I like. And the last one is the operating system level virtualization. And well, guests share resources with the host. For instance, they have the same kernel. We can categorize OpenVZ in this area, for example. The isolation can be weak. So if we don't, if the virtualization system does not control heavily the isolation stuff, host's performance can be compromised by the guests. But well, it also runs very well. So, after this little introduction, I just described how the test bench was set up so you can understand how the testing was made. Well, the equipment was an HP Program ML 310 server. It's a dual Intel Xeon CPU, 2 GB of RAM, and 2 hard drives on RAID 0. Well, we could have used RAID 5, which would give us better hard disk performance. This is pretty important because, well, as you may guess, when we have, for example, 10 virtual machines, there are 10 operating systems accessing the same hard drive at the same time. So we need it to perform really fast. So RAID 0 gives us good performance with 2 disks. Well, we need to back up it, because otherwise we can lose data. But for production use, I'd recommend RAID 5 or more. The operating system level used was Debian 5.0 in 64-bit edition. And for connecting on the equipment, I used the chip 3.com gigabit switch. So, the schema was more or less like this. We had the Asterisk server, and to simulate real calls, we had a SIPp instance running on a host, running as a UAC, thus originating calls to the Asterisk server. And on the other side, we got a SIPp running in UAS mode, so it receives the calls from the Asterisk. Both of them use custom-made scenarios, which are little modifications from original ones, and you can see them in the compressed file I introduced some slides before. So, the software used for testing, well, the Asterisk itself. I used, as I said, SIPp for stress testing, PCP-dump for sniffing RTP, because the tests I made were not just signaling, they involved bidirectional media. And for having CPU, disk usage, memory, stats, I used a sysstat utility tool, which has 2 utilities. For example, one is SAR, which makes binary stats, and SADF, which extracts data from that binary stats and converts it to a CSV file, so I can fire up OpenOffice and make some nice, cool, and sexy looking graphs. We also have to extend system limits, because if you start stressing Asterisk, you will find that you can't make many calls. That's because you often reach the open file descriptor limit, which by default in Debian is 1024. And so we just extend the limits, the stack size, the open files, and the user processor, so we can stress the server in that. We didn't do that, I'll explain why. But let's see. Well, the testing itself. Let's start. Well, the testing was made this way. We said 2,000 calls with SIPp. Calls lasted 100 seconds each with RTP bidirectional media and with 400 simultaneous calls maximum. Why 400 simultaneous calls? Well, the purpose of this testing was not to get John Todd's stick or just to test how Asterisk, how much calls Asterisk could process. It was just to test if Asterisk could run well in a small, medium environment when running virtual. Because if we want to handle 1,000 simultaneous calls, well, we buy a server and use it for that. But the thing is, maybe we are thinking about hosted PBXs, and we can think of buying a really big server and host several small PBXs inside them. So we really don't need 1,000 simultaneous calls, because otherwise we'll use the spare server for that. So well, for originating the calls, we use the first line. You can see SIPp, all that. Where the only important stuff up there is just that we use M, it's 2,000 calls. The limit with L is for 400 calls. And, well, media interface, media port, and trace stats, so we generate really cool stats in CSV. And for receiving the calls, we use the second line, And we, as you can see, for having bidirectional media, we use the option RTP echo. So that, as we saw here before, this server would originate media to Asterisk, then it will get here and this would echo it back. So then we have bidirectional media for all the calls. And at the same time as we fire SIPp to start originating calls, we fire SAR with all those options, so we get process number information, Ethernet device information, open socket information, CPU information, memory information, and we take the values each 10 seconds. We generate the binary file, stress.sar, and then with the second line we convert it to CSV. So, let's look at the results. When running Xen, the total cost generated for every case was 2,000, as I said, and we had more or less 950 successful calls. I'll explain this in a few slides. And we did reach the maximum concurrent calls. We did reach that limit of 400 calls. When running KVM, we could only reach 530 successful calls, but we also did reach the maximum concurrent calls limit, so we were running at 400 calls simultaneously. And with no virtualization at all, we got the best results. We got 1,000 successful calls. Well, these are the graphs. You can see in blue the total calls created, the successful calls in orange, and the failed calls in yellow. Sorry. As you can see, well, failed calls are fair enough, are a lot, and after we go through all the graphs about calls, I'll explain why this is like it is. But as you can see, KVM performs, at least in my tests, I don't know if maybe you achieve better results, but in the tests I made, I couldn't get better ones. And these are the results with no virtualization at all. And so, why are these numbers like this? Why do we have half calls successful, half calls not successful, more or less? Well, that's because the SIPp scenario used is really tight. It's really strict. In the real world, we would expect retransmissions at SIP layer, and we may wait at least forever. But the SIPp scenario is very tight in the respect of which responses it waits for. I mean, in the SIPp scenario, after receiving an invite, we may expect 180 answer, but if we get 183, which is not the case, for example, that would not match this scenario, so that would be a failed call, at least for SIPp. So I made another graph, just comparing the failed calls because of maximum UDP retransmissions reached. And as you can see, with Xen and with no virtualization at all, calls are very few calls, less than 20. So the other calls are, we can say that the other failed calls are not really failed in the terms that Asterisk couldn't process them. They're failed because they didn't fit exactly this scenario. Well, talking about the CPU usage, as you can see, well, we can see in blue the user applications and the system applications in orange, and the I/O weight in yellow. The I/O weight doesn't really matter here. But well, as you can see, the load is more or less 70% when using Xen. When using KVM, we are moving out the 80% of CPU usage, so it's a little higher. And with no virtualization at all, we are at 45%. So, by looking at this, we can conclude that when running Xen or KVM, we would reach the 100% CPU usage earlier. And that would mean we had to stop processing calls at some point of time. But as I said before, our purpose was not to test how many simultaneous calls Asterisk could handle. It was just to test if Asterisk could handle, well, a good number of calls for a medium server usage. We're talking about memory again. Well, really, Asterisk eats more CPU than memory. I didn't really have any memory issues here with the tests. As you can see, this is the Xen percentage of memory used. Both guests, KVM and Xen, use 1 GB of dedicated RAM for them. That's the memory usage for KVM. And that should be the memory usage for the server running standalone with no virtualization at all. So, as I said, we have no issues here with memory. That's not really the problem. And, well, these are really, really important, the socket activity diagrams. Well, as I said, if we didn't put up the limits, we could reach those annoying errors on the Asterisk CLI, too many open files, so we couldn't get more calls, because we can't open more file descriptors, for instance. So, by looking at the results in Xen, we are moving in more or less 1,600 open sockets.
1,600 for 400 simultaneous calls?
Yeah, for 400 simultaneous calls.
We have 4 sockets per call.
They are RTP bidirectional. We have SIPp and also RTP. And in KVM, well, it's a little more irregular, but we're moving in the same, mostly the same values. We have 1,500, 2,000, we're moving in there. And with no virtualization at all, we're in the same numbers. And well, what does this mean? As you pointed out, that's because of the 400 call limit. Because we have signaling and we have RTP bidirectional. So as in the 3 cases we reach the limit, we are moving in the same numbers here. Well, now let's talk a bit about tweaking, or what had to be done to achieve better results. When talking about Xen, Domu, which is the guest, run in an LVM volume. Why in an LVM volume? Because it's really important that the hard drive is fast to write, and for the operating system to perform well. And in Xen we can run this from just a single file, or we can have a physical partition and use it. Sorry. And that's why I used LVM and just assign a volume to the guest, so he uses a real partition and not a partition, a file, which is less efficient. We also use 1 GB of RAM, as I said, and this is important. Disabling the Ethernet checksum for the Domu adapter gives us better network performance. Why? Well, because there's no real wire between our guest network card, because it's a virtual one. So we really don't need to check if our packets would go out well, because they will. There's no kind of loss on the wire, because there's no wire. So we achieve better performance by having the checksum turned off.
I'm not familiar with them, actually, but don't they have a modulator where you can running around Ethernet interface bridge mode? Because if I understand, you use the hostess mode.
No, I'm using Ethernet bridging for the virtual guests. But inside the guest, then you can, he sees a virtual web. You have all those virtual interfaces bridged on your host. But then on your guest, you just see one adapter, which you think it's your physical adapter. You can turn the Ethernet checksum off there, in the guest, not in the host, but in the guest. And it gives you better network performance.
Is there a possibility to assign a physical adapter to the guest?
Yes, in Xen we can do PCI pass-through, so we can bypass PCI cards from the host to the guest. Well, this is really good because we can, for example, pass pigeon cards also, well, or whatever, TDM cards. We can pass them to the guest operating system also and use them there. Well, we have also had to tweak datidummy.c so that it correctly handles timing source. Well, we won't need this anymore when, as Kevin pointed out earlier, we are having now new timing sources as for 1.6.1 and so on. So maybe we can use them and get rid of using datidummy for timing, because in Xen we don't have access to the RTC, to the real-time clock, nor to the high-precision event dimmer or HPEP. So we just need to comment out those lines at the start of datidummy.c so that it doesn't get confused.
Also, DADI 2.2 has those changes in it. So if you want to still use DADI because you're not using a new enough version of Asterisk, you will do the right things in Xen anyway.
I'm happy to hear that.
Yes.
Because I had to edit it by hand. So, well, it's 2 or 3 lines, but well, I have to hear. For KVM, well, as I said, KVM is a full virtualization environment, but Xen is a para-virtualization environment. Well, there are some differences in here, but in KVM, we can use para-virtualized drivers for block devices and for network devices. These drivers are called virtual drivers, so we can have a full virtualization environment, but it's running para-virtualized drivers, so it gives us para-virtualized performance on network and block device, and that's what we need in this case. So that's what we use. You can look at the configuration files, as I said, on the compressed file. And well, we use the same testing scenario for KVM. So we got, the guest was on an NVMe volume, there was 1 GB of RAM dedicated, and system limits were also extended. And so let's analyze a little bit the results. Well, only really few calls were dropped because of maximum UDP retransmissions, because of poor network performance. So that's nice to hear, because, well, with this amount of simultaneous calls, both well, virtualization technologies that were tested performed well. The other, well, the 90% of dropped calls exceeded response timeouts, etc., but of the SIPp scenario. So please don't get confused and think that, well, we lost half of the calls, because that's not really true. It's that they didn't exactly fit the scenario. Well, I tweaked the most as I could, but it turned out that way. It's strict in the meaning that which responses we expect. And well, I didn't see too many open files message on the Asterisk CLI, so I assume and we know that by extending the limits, we can put up the limit of Asterisk simultaneous calls. We didn't want to reach it because we put our limit at 400 simultaneous calls, but well, that's a nice number for a medium PBX, which is the one we want to virtualize. And well, 100% CPU usage was never reached, so that's also interesting. And well, what we also know is that networking tends to be slower when running virtual. You can try it using utilities like iPerf and see that when running virtual, your networking speed slows down. So we just...
It has to copy packets. It's a packet copy which is slow. Because it has to get the packet from physical interface
and then go to the virtual interface and all that. That's the problem. So because of that, we use the para-virtualized drivers in KVM. We don't need them in Xen because they are already there. But yeah, that's the point. And well, I have to comment a little bit what issues arise during the testing period because, well, the important thing is that if we want to stress an Asterisk server, we need a bigger Asterisk or a bigger server on the other side because otherwise the stress machine will get stressed before, which was the thing that happened to me. I was generating calls with my workstation and it blocked. And I was like, how the hell this is happening? I don't even have 300 simultaneous calls. Well, I took a bigger machine and then I could make good tests. If we want to try 500 simultaneous calls with 1 Asterisk, we'll have to divide and distribute the load and attack the Asterisk server with several laptops or workstations because one single machine can't stand with all that, at least with RTP, which was the case. You also had issues with SIPp. If you download latest release from SourceForge, you'll see that it doesn't compile. It's a silly line on an HPP file, but well, after trying that release, after doing a checkout from trunk, I found that the most stable release for me was the snapshot from the 21st of January of this year. I got segmentation faults with other releases and didn't with this one, so I'm happy with this release. And it's also really important to have network isolated when doing testing. Because if we are going through our office switch where all machines are connected, our results can get altered and we can get what we really want. We want just our traffic. If someone is downloading with BitTorrent or anything like that, results can get altered. So for testing, the best is to have the network isolated. And so, what are the conclusions I get from all this? Well, as Obama said, yes, we can. We can use Asterisk in a virtualized environment. It runs, it works, that's nice. But we have to take into account some performance factors, which I named there are 3. The hard disk drive, well, we can use fast hard drives, we can use SAS, we can use iSCSI, RAID 5, etc. Just as fast as we can. With networking, it's also really important. So if we use a full virtualization environment such as KVM, we should use para-virtualized drivers. And also, we should spend money on expensive and good network cards because that really matters. And the CPU is also really important. As we are sharing, that's the important word here. When we are running several virtual machines, we are sharing the resources from the physical one. So we need to have lots of CPU power and lots of networking power so that when we share, each one gets what it needs. As I said, we tested a decent amount of simultaneous calls, which I repeat was 400. But if we want more power, well, why don't use a single server for that? We're testing virtualization. We really don't want to virtualize 10,000 simultaneous calls Asterisk. That doesn't make sense. Well, there are also some advantages of using virtualization. We can use cards. We can use TDM, ISDN cards on the virtualized guests. We have PCI pass-through, so we can use, if we have, for example, 2 4PRI cards on the server, we can have 2 virtual machines and assign a card to each one. So we have 2 servers running in parallel within one single physical machine. And that is cost reduction, which we talked about on the first slides. And well, I found that especially for testing purposes, because I like to test lots of stuff, latest Asterisk release, latest free switch, everything. It's really cool to use virtualization because we can make different sandboxes for our testing without breaking anything. Well, thank you all for watching, and I have to thank also the MooCon crowd for letting me come up here and tell me stuff. Well, if you have any questions, I'll be happy to hear and try to answer.
Do you have an idea what the time span was for the calls? Do you have an idea of the time of the amount of calls per second maximum, for example?
Maybe it wasn't in the line, but the pace, no, I forgot to put that. The pace was 5 new calls per second. And SIPp stops starting new calls when it reaches the limit. So you have 5, when you reach 400, then it stops, and when calls get hung up, it starts at 5, all again.
So on this machine, you under Xen, you have 70% system load.
Yeah, I had 70% basically.
So basically, you can't run another instance of Asterisk on this machine.
Yes, because I have more cores. It's just one core for each. Yeah, just one core. Just one core. So if I have an 8-core super server with tons of RAM, I could assign 1 or 2 cores for each virtual server, so each one has what it needs. But this one, I forgot to mention that, but it's that each virtual guest run with 1 single core and 1 gigabyte of RAM.
Have you looked the time difference between the outgoing and the echo? Have you looked the time lag between coming out of a package?
I don't really get the point of view.
So the thing is, if virtualization adds latency to all the SIPp signaling and media signaling, I mean, with the virtual Ethernet bridge and all of that, how many more milliseconds are we adding?
Well, I didn't measure it. I have to admit that I didn't measure if it was 5 or 10 or milliseconds, but it's not enough to get it bad. I mean, it runs just like it runs well. If you are running virtual, you don't get 100 milliseconds latency because of that. Because networking virtual devices are really good. KVM ones, virtual ones are good, and Xen ones are also really good. They are integrated with the Xen kernel, which is supposed to go to mainline on the 2.6.30 release. They really perform well. You don't have that network, the networking power you have with a physical network card. But well, people advise that if you are about to use an application which really has a huge network usage, you should PCI pass through a real network card, so you get the same performance. I hope that answers the question.
So that's interesting. A comment.
Yeah.
When doing the tests, you really didn't test stuff that SIPp is good at. So for these tests, I would prefer to actually use Asterisk for generating and measuring the load. Because as you say, SIPp is extremely strict in the dialogues, and Asterisk can actually accept other messages, and it's easier to follow up if after it's denied because of local files, and also measure a couple of other things. It might be that Asterisk is just a tool I use for everything, because everything is a name.
Yeah, well, I just SIPp
because in this test scenario, Asterisk would have been perfectly good if you have 2 or 3 laptops on each side of the server.
Yeah, well, yeah, that's true. I just use SIPp because, well, I don't use it much. I like to learn about it, and also because by reading, if you Google around Asterisk stress testing, SIPp comes around every time. So
if you want to stress test Asterisk, but here you measure the difference between you running Asterisk in different environments, Asterisk will be working well. But if you really want to stress and see if the virtual machine can handle an attack of 500 calls at Asterisk within no time, SIPp would be the tool to use.
If you would use Asterisk, you would have the results would not be exactly the same, and you couldn't try to estimate what it would be with other hardware, faster hardware, etc. Because you would have to start to have retransmissions, other attempts to retry signaling, etc. So your 5 calls a second would no longer be valid. They might be 50 calls a second at a time, etc. So you will no longer have a fluent straight line. You see the performance difference between beginning with 5 simultaneous calls and 400 simultaneous calls. You have more like such a graph.
yeah, but maybe you could script that. I mean, that line, a little bit, but well, it would have been hard, I guess. Any other questions?
Maybe another short comment. I was trying also some stuff with SIPp, and basically you can also define some optional responses. So because I had also problems with this 180, 183, and so on.
Okay, I do have.
If you catch a bit more, then you get, let's say, modify your statistics, but you get out those messages that are relevant that you don't expect, basically.
Well, I cast the provisional response that Asterisk was about to respond to me, and those were the results that came. Maybe by tuning up the scenario, results would have been a little different, but well, I was happy to see that it really performed well, which was the point, and in the end.
Isn't it possible to configure SIPp channel, SIPp channel enter so that there are no provisional?
Don't really know that. Maybe Paul can answer that question for you.
Or is it possible to?
You will always get some provisionals.
Yeah.
I mean, you have to get some. You
Yeah,
have to get time to try.
the idea is that's always the same. That's the idea.
Well, we can't have all this the same, because if something fails in Asterisk, you have to signal in a different way. I mean, but you can in SIPp actually scripts, you can accept different scenarios, but it's not as easy as it is in the Asterisk dial plan. And saying that the Asterisk dial plan is easy is well, can be discussed. It's really hard, but you can have SIPp handle all those situations. So it's doable. But SIPp is a tool for real sick men. Yeah. There's also a tool in somewhere in Asterisk SVM that can take Asterisk. You have to correct me now, Kevin. Can take Asterisk SIPp debug and TCP dumps, one of those, and convert them to SIPp scripts for testing.
No, it's not an Asterisk, it's a separate tool.
Yeah, it's a separate tool, somewhere in our SVM.
Take the capture and turns it into a SIPp scenario.
Yeah. So if you have a scenario that you really want to test and then try to develop a fix for, it creates a SIPp scenario so you can repeat stuff.
I really didn't know that tool existed.
Yeah, it hasn't been published much, it's just out there.
How was it called?
It's called SNIF to SIPp, Xen and HyperVM.
Is it available?
Yeah, it's in our public SVM repository.
Well, I'm checking later
Yeah,
today.
and so you can just give it a packet capture and tell it whether you want a scenario to be the UAC or to be the UAS, and it will just create one. I guess you should probably announce that somewhere. Because it is rather handy.
I think there's been a few mails about Terry on this project. No big fanfare or...
Yeah.
Are there any other questions?
Why did you put the stack to unlimited?
Sorry?
When you described your settings, you said you limit one S unlimited. In in most cases that would slow down your machine quite a lot.
Well, because if I didn't do that,
Yeah.
I would get too many open files errors and I couldn't.
On stack?
No, sorry, on stack was because of SIPp. SIPp got hung and I got segmentation faults if I didn't rise the stack value. So I found that setting it to unlimited just worked for me. Maybe it's not the best setting, but it's the setting that made the stress machine generate all the necessary traffic to the Asterisk server.